Welcome, and today I am interviewing a professor from computer engineering at University of Puerto Rico, and it's Nayda Santiago, right?
Yes.
Good?
Correct.
Okay, so just to tell the viewers, the students listening, can you tell us a little bit about your background and what you do?
Okay, so my background, my PhD is in the area of high performance computing from Michigan State University. My master's is from Cornell University, and my undergraduate is from the University of Puerto Rico, Mayagüez.
Great. And what kind of classes do you teach?
I teach computer architecture and the capstone senior design project.
And I know that you're interested in software engineering,
Correct.
right? And that's one of the things we're both currently in a Google program called Faculty in Residence that you're working on.
Correct.
Great. So you are the perfect person to interview and give a different perspective to students about like best practices in software development.
Correct.
So with that in mind, I have a series of questions that hopefully you can give your opinion to students. So in the different projects that you've worked on over the years in research or in collaboration with industry, how have you done specifically the design process, so talking to design? How have you done that?
Okay. The design process depends actually on the actual project.
Okay.
So at the beginning, when we were starting to do the senior design project, we would use a similar template to every student for every project, but we realized soon enough that every design deserves their own particular methodology. So there are software designs that require agile methodologies. There are software design that will probably go to the traditional waterfall model. But the methodology is actually dependent on the actual project, the scope of the project, and the needs of the client. Sometimes the client will require something that is pretty fast and that they need some base code and then adding features. And sometimes the clients just know all the requirements beforehand, and they just need a full design and the whole process using the waterfall model.
So you mentioned something kind of early on, which is design document.
Correct.
So what do you think are the important elements in a design document?
So it's very important to have the software architecture.
Okay.
It's very important. I use a lot UML diagrams.
Okay.
Because our designs are not as complex as probably very
large
huge
base
code, but UML diagrams, depending on the actual design, is the type of UML diagram that they require.
And so for those kind of beginning students, UML does things like describe the usage of software, for example, with a use case diagram.
Use case diagrams, sequence diagrams. Sometimes it's a flowchart what they require. Right. So it depends on the actual project.
And typically you'll learn how to do those kind of diagrams your sophomore, junior year, depending on when you take software engineering or the equivalent of that. But so the important part there is like describing how the system's being used in some way through a diagram, and then maybe the beginning parts of breaking down the code.
Correct.
Modularly.
And most of the time, the students don't realize that the documentation is very important for themselves. It's very important for establishing the communication between team members.
Okay.
If they don't document it proper, in the process of documenting, they are agreeing in how to design, and therefore their actual design comes easier after the design documents have been established.
And do you think that for programs that do have a presentation layer, an interface, that doing mock-ups and things like that can be useful?
They do mock-ups if they have a front end, yes. Okay. It's very important.
Okay, good. Yes. And how about when, I know you mentioned like architecture. So there's kind of, in my mind, like two different ways. One is like how you might separate the software itself into pieces. And the other part is what are the actual components of your system. So you might be doing a web-based system, and you might decide I'm going to use Google Cloud, and then maybe you have hardware, and you maybe have an Android device. And so there's kind of like this large system architecture, and then there's kind of like the software architecture. Do students in common do? Well, I guess it depends on the scope of the project.
Correct.
But do they do both, and they separate these two? What happens?
What I normally ask the students is, give me a system view. If it includes hardware and software, then they should define both components.
Okay.
But in terms of software, then they will have to give me an overview of the whole software. So it could be a layers diagram, a diagram made of layers on the software. It could be the components of the software. It depends on how. There is no one size fits all, so it depends on actually what works for them according to the particular project they are doing.
Okay.
Sometimes it's much easier to have a layer diagram rather than system components, but it depends on how they have divided the components of the software.
So since we're trying to talk about best practices and actual, in this case, one aspect of that is tools, right?
Yes.
Through the whole development process. So like, just to be simplistic, you have design, and then you have implementation, testing, which can be a cyclical thing, and then you have like delivery and documentation. So kind of separating it basically like that. What tools do you think are important in each of those? So you already talked a little bit about design, but what about specifically implementation and testing?
The typical way that the groups in senior design project work is using what is called the B model, which is they do understand the problem, they do the specifications, then they do the design, and then do the implementation and testing and validation, and then production. So it would be like the B model. There are two aspects of the design. One of the aspects is the technical aspect, and the other one is the managerial aspect. So for each one of those, there are tools. For the technical aspects, it depends on the particular language they have used. And also, some of students would like, for debugging purposes, they would like to use a ticketing system. And for managerial purposes, they have to work on timelines, milestones, and how to follow up on issues.
Okay.
So some of the students will use Trello, Asana, Microsoft Project.
Right.
There's another tool that they use that is called Instagantt, so they can follow the Gantt chart and following what the baseline of the deliverables are. In terms of testing, they have to implement tests.
Okay.
So if it's hardware, it's tested one way. If it's software, it's tested in another way.
And is it so? There's maybe 3 levels of testing at a very high end, like unit testing, where you're testing small pieces of code.
Correct.
And then integration, and then kind of system and acceptance testing.
Correct.
Kind of at the end. You focus more on unit testing?
They do all of them because they have to. Each component has to be unit tested.
Okay.
Each component, and then when they are integrating them, they have to do integration testing. And we don't accept a project until it's accepted by the user. So there is an acceptance testing.
So for the unit testing, a lot of times that can be integrated into IDEs, but the frameworks are specific to maybe languages. What have you used in the past?
Well, the majority of the students uses Java. So in my case, so they mostly use JUnit
for unit testing. And how about for the kind of system integration level testing? What are they doing?
It depends on the particular project, but in the case of system integration, most of the time what they do is integrating their own tests. So it would be bit by bit integrating each part separately, and then testing all the stream case, more manual processing.
Okay. That's great. And then moving on, like when we're thinking about version control, which is somewhat related to, you talk about issue tracking, because oftentimes
they go together.
So what tools, kind of focusing on that, do you find students use?
99% of the time they use GitHub.
Okay, so they're using Git with a GitHub repository of some sort. And okay, great. And when are students starting to use that? I know you mentioned your capstone project, but are they doing it in earlier classes?
In the advanced programming class, they start using GitHub.
They start using it like kind of the junior level, sophomore year level year?
Sophomore. Yeah.
Sophomore, okay. So team collaboration is really important, right?
Yes.
In today's world, you don't write programs by yourself. And so what do you think in terms of communication tools are important for a team?
Well, my experience, teamwork is much more important than technical skills.
Okay.
Usually when a team works well, they do help each other, and the project is it comes out easily. It's very easy to test. It's very easy to work with others. So usually we have a better outcome when they have good teamwork and good team dynamics rather than having technical skills and not having good team dynamics. In order for them to work well in teams, we have trainings on how to cope with conflict.
Okay.
So to make sure that they do know that there is going to be conflict and they have to find ways of managing conflict. So in that sense, we do that training in the classroom before they started the semester, at the beginning of the semester, so that they can understand that this is common. And so one of the things that we do follow up a lot is individual accountability. So we are constantly making sure that everybody in the team is working, and it's not because they tell us, it's because we sit with them, ask questions, make sure that everybody works. So making sure that everybody works releases a lot of pressure, because most of the time when they have problems, teamwork problems, is that somebody is not doing their job.
So you're kind of focusing on like soft skills and productivity.
Correct.
What you kind of talked about, they call it soft skills, which is how you work with people, how you collaborate, how you get along, right?
Correct.
Exactly. And that's as important as technical tools. And I know you mentioned like doing, like a Trello board for milestones. So that's another kind of communication tool in a way.
Yes.
How about, and then issue tracking is there, but how about like, instant messaging? And you hear about Slack. And some of these things.
Many of the teams like to use a Slack. Many of the teams like to use WhatsApp. They use also Facebook Messenger to communicate with each other. But on the other hand, they are also encouraged to have face-to-face interactions.
And email, right? For
email
larger
is okay.
content,
yes,
right?
Exactly.
Email
is okay.
Messaging is somewhat limited, right?
Correct.
But it's kind of
and also the fact that in email you have to be explain yourself correctly. So you have to learn how to write a correct email, explain details.
And even when you're like with the various like Git, and whether you're using GitHub or Bitbucket and you're submitting things, those messages can go to everyone in the group.
Correct.
As well as like new issues.
Correct.
And you can assign it to other people. They'll get a message.
Correct.
And so that's a kind of using tools to facilitate communication.
And also in Slack, you can also create channels, and the different channels, the information will go to different channels, to different groups of people.
So one of the things that we do very informally is code review. And it's something that we've talked about in the program that we're together. And they have a more formalized version, and in tools, sometimes in industries, different companies, they'll have their own internal tools for doing various things. But how do you in academia support code review?
Well, actually, I don't think that we have practiced code reviews, but now that I have seen how well they work, I will incorporate them in the classroom.
So code reviews, basically the idea that either before you submit code to the repository or immediately during that process, you would have another person look at your code and basically look at it for styling, look at it also, not necessarily for testing, they assume that you've done testing, but to kind of see that the impact and the dependencies and stuff like that aren't maybe breaking other things necessarily.
Correct.
And so that person would have to be somewhat familiar
Yes.
with the code base, because
Yes.
it's not going to really work otherwise. So it typically would be a teammate with you, or if they're in another team working on a closely related part of the system that interacts, it might be them, if
Correct.
that's something that you're touching on. So two more things. Testing, right? So, test driven versus just kind of test oriented, where you're developing tests after you write code versus prior to write code. What do you practice?
They don't, in my experience, they don't write the test previous to writing the code,
Right.
but they do have to have a plan on how they are gonna be testing. So before they start the design, they will submit an idea of how the software is gonna be tested based on the objectives that they have, and at the end, before turning in the last project, they have to turn in what their tests were, so
Right.
that we can evaluate whether the tests really evaluate what they were looking for at the beginning of the project.
And like we talked about unit testing, which is you develop small pieces of code, right? You don't write large pieces of code. And then you test just that, right? And it's not until you get to that very final stage where you're testing it in many different, like maybe use case scenarios, that everything is really going to work well together.
Yes.
But it is a time intensive.
Yes.
As we're seeing in industry, there may be in some cases, if you're a very test oriented team, you might have more testing code even than you would have actual code.
That's true.
Which is amazing. So to end our discussion, I just was wondering, do you have any general tips to students in terms of, should they try these tools and techniques? How should they develop those skills? We have some construction going on next door, so excuse that. But anyways, what would be your general tips? What do you think is important? What should they do?
Before starting the project?
Just in general, like to develop themselves as software engineers. Do you think it's important to try modern techniques and practice using real tools? What do you think is important?
It's really important that they have practiced a lot.
Yeah.
So practice makes perfect. So practicing using each one of the tools, trying to test those tools under different circumstances in such a way that when they come to the actual final design project, they will know which tool would be better for the particular project they are working on.
Right.
And also try to find a good match in terms of teamwork skills. So it's both the technical aspects and the soft skills. So having a good match with partners that can do a good project together and work along together, it's very important.
And I think the good thing is that a lot of the tools that you mentioned are either open source or they have free tiers.
That's true.
Right?
That's
so
correct.
That means it's accessible to you. And whatever you do can translate into wherever you go, even if they have internal tools.
Correct.
You'll have learned the basic techniques of how to work through a project, and you can translate that.
That's correct.
But soft skills is something I find really interesting. How do you help students develop soft skills? I mean, besides kind of saying, here's a project and work on it, what can they do for themselves? I get that question a lot, like, I want to go and interview at Google and I want to develop, basically they're asking me, I want to develop my soft skills.
Correct.
So,
in our sense, we do a lot of feedback. They, at the beginning, they have to do, for example, presentation skills. So they have to do a presentation, and we give a lot of feedback, and it's timely feedback, so it has to be immediate, and it has to be sincere. So if a student doesn't project the voice well, or stands and the voice or checks a lot, or has some difficulty in answering questions, we tell the students so that the next time they do it better. So it's like many interactions on presentation skills, many interactions with teamwork skills. So each one of those skills that they have to develop we provide a lot of feedback
Right.
to make sure that they understand what they are doing wrong. Sometimes it's the first time that they receive feedback, because sometimes the classes are really large classes. The professor doesn't have a very close interaction with students, so they cannot provide feedback. But when we are in the senior design, it's more close interaction with the students.
So whenever, I guess my tip following what you said is like kind of whenever you can experience teamwork, even if it's not in class, like if you're a younger student, maybe join a club that might be doing hackathons.
Correct.
And there might be stronger students there who've experienced it before.
Correct.
And that would be a way to kind of develop those skills.
That's true.
Both soft skills as well as hopefully practicing with modern techniques and tools.
That's correct. That's correct.
Well, thank you very much.
You're welcome.
It will help hopefully all of you.